When you're learning to use Unity events, you'll often hear people say how slow they are. They bring the benefit of a nice visual interface design to add listeners without any coding, which may benefit designers and probably beginners who are just learning the concepts of events. I personally am neither of those things, and everything else about Unity events seems to be a con. But in an attempt to subvert my bias, I thought it would be a good exercise to actually test how slow Unity events really are. To get interpretable results, you need a benchmark for comparison. The obvious choice here is C# events, but I also wanted to throw in Multicast Delegates, since C# events are just an extension of those. So theoretically, Delegates could be even faster than C# events. Ultimately, I want to have results showing the amount of time each event type takes given the exact same scenario. The variables I wanted to test were the number of listeners each event had, as well as the number of arguments being passed into the event. And of course, to get something readable, I needed to crank up the number of invoke iterations to get meaningful results. The setup consists of one observable object, which contains 0 to 4 argument static definitions for each type of event, and up to 100 listener objects that subscribe to each of the events set up in the observable object. I set the listeners as active or inactive based on how many listeners I want for the current test. The listener functions are the same for each different type of event to keep the results consistent. And yes, making Unity events static completely renders their benefits of having a visual interface useless, but you're not going to catch me adding 100 listeners by hand in the Unity inspector. In the UI, I set how many listeners I want active and how many iterations for each event. I then had buttons representing the number of arguments to run a test with all the given variables. I recorded the results in a spreadsheet with the number of listeners at 1, 10, and 100, and iterations at 100,000 and a million. The number of iterations was kind of arbitrary because it was determined based on how fast my computer is. I also only tested on my PC in the editor, so this is by no means exhaustive testing, but I think it is enough to give a good idea of the difference in performance. Okay, after running this 30 times, I have some results. Unsurprisingly, Unity events are slow, but how slow are they? It seemed on average that they're about 10 times slower than C# events. The execution time increased mostly linearly, both with iterations and with the number of listeners for all 3 types of events, with Unity events being about 10 times slower in every case. And you can see the magnitude of the time on the vertical axis, increasing about 10 times as the iterations or listeners are multiplied by 10. It was also interesting to see the difference between C# events and Delegates. Delegates proved to be slightly faster in every case except for when there was only one listener, in which case it was slightly slower. I don't know why this is for sure, but it's likely that Delegates have a bit more to worry about considering you can invoke it from anywhere, whereas events can only be invoked internally. But if you happen to know why this is, let the people know in the comments. I would also be interested in knowing if anyone actually uses Multicast Delegates instead of C# events. So the results proved the original assumption that Unity events are definitely a slower approach, but it was also kind of interesting to see Delegates in action. I might even start using them more often when I don't need to be concerned about encapsulation. Something to keep in mind here is that these are heavily amplified results. It's unlikely you'll ever be firing close to 1 million events in a frame, and even having more than a few listeners at a time doesn't seem very likely. Using Unity events is not going to kill your game if you're just using them for the occasional data sharing, but it's good to know that if you start putting them in the update loop, they will start causing frame loss a lot sooner than C# events will. Anyways, that's all for this video. If you want to see more performance analysis videos, let me know in the comments. And if you're feeling generous, hit that like button so I know whether people are enjoying it. I have much more in the works, but I'm also looking for what people are interested in. So if you have something you want to see, let me know. I hope you subscribe to my channel and stay tuned for more content in the future.